So the second derivative test works only if there is a critical number. So let's say there is a critical number at C, which means f prime of C is either 0 or undefined. And at that value, the second derivative, you can simply plug it in. You can plug it in the second derivative and see, and then you can decide if you want. So the second derivative is positive, which means this, which means that this is a relative min. And if this first derivative is 0 or undefined, and at that point f double prime is negative, then C gives a relative max. I would recommend this better to check, but it's up to you. You can use it if you like. Okay, so now let's move on to another problem. Okay, before we look at another problem of the same kind with what I call everything, I like us to look at something like this. I should go to the next page. So here is another example that cements what we just discussed. Okay, so I'm looking, I picked from your book on page 306. I like to look at this problem. It will take a minute to copy it. It's quite long. So let's copy it. F prime, so this is 39 and 4.3. So f prime of 5 equals 0. I'm making a point with this problem. You'll see in a moment. For x less than 5. It's not clear. It's not clear. For x less than 5. Okay. F prime greater than 0 for x greater than 5. F double prime of 2 is 0. F double prime of 8 is 0. F double prime of x is less than 0 for x less than 2 or x greater than 8. F double prime of x is greater than 0 for x between 2 and 8. And limit as x approaches infinity from f of x is 3. And the same for x approaches negative infinity, also 3. Okay, let me close this and put it aside. Okay, so we're asked to graph an example. Of a function. So if I ask you what this is, you're going to say, obviously, a mess. No one understands. This is gibberish. But it will become very clear if you bear with me and agree to use this table. Okay. So let's see. First of all, I can start anywhere I want. So limit of f of x as x approaches infinity, negative infinity. Don't erase anything. I'm just crossing it out. This means definitely this. And I make myself a note. Y equals 3 must be a horizontal asymptote. Okay, now I'm going to analyze the first derivative. The first derivative of 5 is 0. Done, which means this is a critical number. The first derivative is less than 0 for x less than 5. Fine. Done. The first derivative is positive for x greater than 5. Done. Don't erase anything, I'm just making a point. Don't cross out anything, unless you want to, or check, or whatever you want to do. So f prime of 2 is 0. Potentially, I don't know, but potentially an inflection point. We'll see. F double prime of 8 is 0. f double prime is less than 0 to the left of 2, or, which means union, to the right of 8. To the left of 2 is negative. To the right of 8 is negative. The second derivative is positive between 2 and 8. Now it's no longer gibberish. Now it's very clear. And there are infinitely many correct answers here. So, obviously 2 comma whatever you want it to be must be an inflection point. Obviously 5 comma whatever you wanted it to be, what is it?
An inflection point and minimum?
So the inflection points are only when the second derivative is 0. Here the second derivative is not 0.
Oh, is it?
So, right? So this means this means this, and this means this. So it's an inflection point, it's a critical number, and C decreasing and increasing, and this is checked by the second derivative test. So what can this be?
A minimum.
Very good. And finally, 8, whatever you wanted it to be, what is it?
That's an inflection point.
Absolutely. This is it. So from all this gibberish that meant absolutely nothing to me, using the table, analyzing step by step what I'm given, I know exactly how to graph the function. An example, of course. So let's give it a shot. First, I will always start with a horizontal asymptote. Always. When we graph functions with asymptotes, we always start with the asymptote or asymptotes. Okay, at 2, 1, 2, 3, 4, 5, 2, 5, 6, 7, 8. Let's see what happens. Coming from the horizontal asymptote, decreasing, opening down to 2 comma whatever. Okay, fine. Coming from the horizontal asymptote, opening down, decreasing to whatever, 2 comma whatever. It changes concavity, continues to decrease, opening down to 5 comma, and I can put it anywhere I want. So let's say I'm using this. Decreasing, opening up to a relative minimum. Continues to, it's the relative minimum and it's increasing now. It goes up to this point, 8 comma whatever, where it changes concavity. So let's say, here's my point. 8 comma whatever it to be, you wanted it to be. It changes concavity, opening down, still increasing towards 3, which is the horizontal asymptote. Here's my graph of f of x. And I was able to do this after summarizing all the information, analyzing what the points were, and then graphing accordingly. Opening down, opening up, opening down. Inflection points, relative min. By the second derivative test, this is a critical number, 5 comma whatever, the point, right? Opening upward, changing sign. So obviously it has to be negative and positive because it looks like this. Decreasing and then increasing. Any questions on this problem? I hope I was able to convince you of the power of the table, and that you will try to understand it and use it. Okay, let's continue with another example. I close my book again. Okay. So let's look at something a little bit more sophisticated. A trig function will take us a long time. It's up to you if you have any preferences. We can look at a rational function combined with exponential. We can look at a natural log. Anyone has any preferences? No preference. Okay. In that case, you're trusting me to choose. Fine. So let's choose. I like to give that a shot with either the rational or, yeah, let's look at the rational. I'm going to have enough rationals, though, in the next section. So let's look at 62 caught my eye. So e to the x over 1 minus e to the x. I have no idea. It could be a mess. It's okay if it is. Okay. The element of surprise. Okay. Obviously, we start with the function. And what is the first element we always start with when we're asked to graph? What is the first thing mandatory? Always.
Is it domain?
Exactly. So can anyone give us the domain? And you could say no. Of course you cannot, because I have to talk about 1 minus e to the x cannot be 0. Or e to the x cannot be 1. Is there a way of determining this?
X can't be 0.
Excellent. Good. Since I already mentioned that, I have to find the limit as x approaches 0 from the left, and the limit as x approaches 0 from the right of e to the x over 1 minus e to the x, and e to the x over 1 minus e to the x. Good. So can anyone plug it in and tell us what it is? And then we decide how to proceed. What is the top? Well, we know it's 1. What about the denominator? Well, we know it's 0. So we know there is no hope. We know we have to get infinities here and here. We know that. So let's see. You may say, but this is difficult to figure out. If it is, let's do this. 1 minus e to the x. Okay, where's my x? Right here. And I'm just going to plug in numbers to the left of 0, like negative 0.1. And I'm going to plug in 0.1 to the right of 0. And I see it's positive on one end on the left, and it's negative on the right. Okay, fine. That's all I need. Infinity and negative infinity. Now I need these limits. As you know, I have to fill in everything here. And only then I can move on to this and then to this. Okay, so yes?
Question. So if we're doing the whole limit thing and it ends up as something over 0, that's when we know it's infinity.
No. Remember, depends on what you have here. So a number divided by 0 can have 3 different situations: infinity, negative infinity, or DNE. So
Okay.
if I have the limit from either side, then I have to analyze these two to draw a conclusion, because they may be the same on the other side, on both sides, and I cannot write DNE. But when the function is undefined at 0 and the limits, at least one of them is infinity or negative infinity, this becomes a vertical asymptote. So 1 over 0 cannot be, I mean, you cannot conclude and say it's DNE. You cannot conclude infinity or negative, you have to determine them. But there is absolutely no hope. Such a limit never has hope. It's one of these three. Is that okay?
Yes.
Thank you. So then limit as x approaches negative infinity of e to the x over 1 minus e to the x. Where is the numerator going when x approaches negative infinity? What is this approaching?
Infinity.
Careful. So e to negative infinity is 1 over e to infinity. I shouldn't write this. This is not legitimate, but I have to write it to explain. And where is this going?
Is it 0?
Very good. So the numerator goes to 0. Let's see where the denominator is going. We already know where this is going. Where is this going again?
Could you move the paper up and over a little, please?
Yeah, I couldn't see that it was negative infinity there.
Sorry. Always keep me on track. I have all these devices. I can't see. I switched my chair and I'm so high up I can't see anything. So keep me on track. So where is this going? It's the same. It's the same e to the x. When x approaches negative infinity, 0, right? But where is the entire denominator going?
1.
Yes. How much is 0 divided by 1?
Just 0.
Excellent. Which means that we have 0 here. Y equals 0 horizontal asymptote at negative infinity. Could it be at the other end? Let's see. This is not a pure irrational function, so we can never conclude. We have to test. Okay, so then limit as x approaches infinity, e to the x over 1 minus e to the x. Where is the numerator going?
Infinity?
Excellent. Where is the denominator going?
Would it be negative infinity?
Yep, it doesn't matter. What do we do in infinity over infinity?
Is that L'Hopital?
Excellent. Because functions are differentiable, we have a limit, we have a ratio, and so, etc., etc. Can anyone give us the derivative of the top?
E to the x.
Can anyone give us the derivative of the denominator?
Is it negative e to the negative x?
Why negative
Or
x?
I don't know. I was trying to remember like what the rule was. And I was
There is
getting
no rule.
back.
It's just e to the x, right? Same thing.
Mhm.
Good. What is the answer?
-1.
Excellent. Y equals -1 horizontal asymptote at infinity.